So, welcome for the lecture 24, that is a organic field crop management. So, especially for the cereal crops we will be discussing. So, last class we discussed about vegetables. So, if you see the organic input management, especially the nutrient management for the vegetable crops and the cereal crops, the crops responds differently. You can grow the vegetable crops with full amount of organic nutrient or the required amount of organic nutrients. You can attain the yield levels in case of vegetables, because in case of the cereals there is some because they are the determinate crops, they require the nutrients at specific growth stages. So, having organic fertilizers to meet the nutrient requirement of the crops at the specific stages, that becomes a cost challenge, especially for the cereal crops, and to meet the yield potentials, having the organic nutrient management is also a challenge. However, by integrations of the beginning of the organic farming, how you can go for the integration of the organic and the chemical fertilizers, we can maintain the yield levels, and slowly we can reduce the use of the chemical fertilizer and fully convert to organics. These things we will be discussing the coming lectures when you go for the transition to organic farming. So, let us discuss about the cereal crops. Two crops we will be discussing here, rice and wheat, how we can have a management of the rice and wheat crops in organic farming. So, rice is a family, that is a Poaceae family, is a origin of Southeast Asia. Climate requirement known, this the rice is grown in hot and humid climate. So, it is best suited in regions which have the prolonged sunshines and an assured supply of water, because rice is a water loving crops. It needs the water, though not standing water, but needs saturation throughout the growing period. And the average temperature required for the life periods of the crop ranges from 21 to 37 degrees Celsius, and at the time of tillering the crop requires higher temperature, so that the tiller formation is better. The temperature required for the flowering stage that remains less than 30 degrees Celsius, around 26.5 to 29.5 degrees Celsius, but at the time of the ripening or say grain peeling periods, it should be between 20 and 25 degrees Celsius. Rice is a short day plant, usually it is grown during the monsoon seasons, that is a kharif seasons, when there is the day length is a decreasing trend, that the flowering behavior starts in rice. So, that we see as a short day plants. Soil, rice can be grown in any type of soil, that is bearing soil type. The major soil groups are, that is alluvial soils, red yellow, red loamy, laterite, coastal alluvium, red sandy, mixed red and black, and medium and shallow back soil. The pH for the rice optimum range 5.5 to 6.5, but it can be grown in wide range of pH up to even if the 5 to 8. Land preparation. So, we grow rice as a two type of rice cultivation system. One is called the upland rice, that is a direct seeding, and the other one is called the lowland rice or the medium land transplanted rice. So, basically direct seeding rice and the transplanted rice, the two system of rice cultivation. Direct seeding rice usually followed in the regions where there is no assured rainfall is available. There is a variable rainfalls or the low rainfall regions, and the places where water cannot be stored for longer periods. In those locations, in those places, we can go for the direct seeding, or the especially upland ecosystems, which unbounded uplands, water cannot be retained, and there we go for the direct seeding rice. But other cases, medium land, lowland ecosystems having assured rainwater, water can be stored. In those cases, we go for the transplanted rice cultivations. So, first we can go for, you can discuss about the upland rice, the direct seeded rice. So, in this method the soils are not puddled, that is only for the either the tillage operation, the primary tillage, secondary tillage, the conventional tillage operation is done to have a loose seed bed, loose soils for sowing of the seeds. So, that is done by the construction of bonds. We can have a raise in case of upland ecosystems, we can raise the bonds. So, if there is a rainfalls, so that the water can, so it do not allow the runoff loss of water can be stored. bond should be well compacted and properly sealed with no cracks and holes there. So, this will minimize the water losses through seepage. It can store the water in case of the upland ecosystem. So, they are tillage we go for primary tillage normally undertaken when the soil is wet enough to allow the field to be plowed and strong to give the reasonable level of traction. So, this can be immediately after the this can be done after harvest of the beginning of the next seasons depending upon the soil moistures and the water availability that plowing is done. So, we do prefer to have a summer plowing. If you go for the summer plowing in case summer plowing, so the soil is opened as a primary tillage and it can helpful for the storing of the rainwater, recharge of the rainwater. Otherwise, if there is no non-plowed soil, the water may be lost as runoff loss. So, this type of tillage operations for the direct seeding, I can go for the secondary tillage as a loose soils, then you can label and sow the seeds. The seeds can be sown in case of direct seeding as a dry seed. It is sown and when the area receives the rainfall due to the monsoon rain and the seed can germinate, and the sowing should be advised looking at the monsoon pattern or the rainfall pattern. It should be because after once the seed germinates and it comes to the above the soil surface, emergence takes place, and if there is a dry spell for the even if for 1 week, it will affect the crop growth. There may be complete mortality or the death of the whole crop. So, this sowing should be done in such a time that so the crop should get the assured rainfalls for the establishment phase at least up to tilling stage when the crop tries to establish. In case of lowland rice or say puddle transplanted rice, so this is done where there is a rainfall amount sufficient available for the crop growth and also the field has a capacity it can store water for longer periods. In that case, you can go for the transplanted rice. But if the other cases where there is the shortage of rainfall, deficit rainfalls, abnormalities, we go for the direct seeding because if there is a direct seeding when the crop establishes after tilling stage, if there is a stress, the water stress due to the less rainfalls or the dry spell, the crop can survive the dry spell. But this may not happen in case of the transplanted rice. The transplanted rice is less adaptable to climate variability or the dry spell conditions. If there is a dry spell even if for 1 week, there may be failure of the crops in case of transplanting condition. So, you go for the puddling, especially this because of the puddling, because when you go for puddling, the land should be plowed immediately after harvest of the previous crop, preferably with the mold board plow that breaks hard pan and keep the soil loose, and this facilitate sowing of the operations to be completed on time. Soon after pre-monsoon showers, to summer plowing also done for this in April May can keep the land ready for timely operation. Then you go for the puddling. Puddling means by plowing the land or tillage operations with the standing water. We impound the water in the field and go on the plowing operation. So, that causes the destruction of the soil aggregates. That is a destruction of the soil structure. We are destroying the soil structure through puddling operations. So, that means the puddling causes physical destruction of soil aggregations and non-capillary pore space, as a result of which individual soil particles gets segregated and dispersed, and that is a leaving the soil mass into a short puddle. In this case, through puddling operations, as you go for puddling, the soil particle gets dispersed from each other. So, if you as you see, if you take a soil in a beaker and mix in water, sufficient amount of water, mix it thoroughly and leave it for some time, you can see. So, there is settling of soil particles. So, initially the sand settles, being the heavier particle settles fast, followed by the silt particle, the next heavier settles, and finally the clay particles that clogs the pore spaces. So, by puddling operation the pore spaces are clogged. So, that creates an impervious layers. So, due to that, so there is no downward movement of water. That means that checks the deep percolation loss of water, which helps in maintaining standing water in the field. So, that is why when you go for the puddling operations, usually it maintains standing water. Water can be maintained in the field, and during puddling, as water is maintained, it is less prone to less weed infestations, because weed growth will be checked due to continuous maintenance of standing water under the puddle transplanted rice. And yield wise, if you can see the compare direct seeding and the puddle transplanting, yield wise the puddle transplanting rice they have the higher yield as compared to direct seeding, because there is some soil chemical property changes in the puddle conditions as compared to direct seeding. There are many nutrients they are available because of the reduced conditions created in case of puddling. Standing water is maintained. So, that helps in availability of many macro and micronutrients, and the response to external uptake nutrients is less in case of puddle transplanting as compared to direct seeding. So, after the puddling you can level the field and you can go for the planting of the rice. The advantage of transplanted rice means it helps in maintaining optimum plant population. Unlike the direct seeding, there may be sparse populations, but in case we are planting in the with uniform spacing, so we can maintain proper populations, and that facilitate uniform healthy crop stand and equal opportunity to utilize space, light, nutrients and water. So, that is one reason why the healthy the stands uniform stand population. So, that also enhances the yield of the crop in case of the transplanted rice. Then weeds are substantially killed in this process of puddling and subsequent submergence as you maintain. So, there is a less weed growth. So, less competition of weed to the crops gets better nutrients, that also that helps in enhancing the yield of the crops in transplanting as compared to direct seeding crops. So, this is the conventional method of transplanting. Also we just say we go for the another method, system of rice intensification. Usually for organic farming we do recommend to go for the SRI, system of rice intensifications, because here we use young seedling as compared to conventional. The seedling age is 25 days, but in case of the organic systems we use the young seedling, the 15 days young seedling, and the spacing is wider spacing, the 25 centimeter, as conventional it is 20 to 15 centimeter spacings. And when you go for the plantings, number of seedlings per hill, we use 1 seedlings per hill in case of the SRI versus 3 to 4 seedling per hill in conventional. And the water maintenance, so you maintain saturation water in case of the SRI versus plus 5 centimeter or more than 5 centimeter standing water in conventional. So, these are the basic differences in case of the SRI systems with the normal transplanted rice. So, having SRI systems, you are using the young seedling, we have the different nursery bed raising technique for SRI systems. There we can use the Dapok method of nursery, you can say. There the seedling can be ready for transplanting within 15 days. If you delay, because the seedling density is around 1 kg per meter square in case of SRI. So, because of higher seedling density, because seedlings are prepared not on the soil surface, and putting a plastic sheets or polythene sheets, or in the seedlings can use thin layer of soils, maybe 1 centimeter soils is with vermicompost mix is kept, and on that the seeds are sown, the sprouted seeds around 1 kg per meter squares, this is covered by again thin layer of vermicompost, and the sprinkling water is done not to avoid any type of water stress, so that the seedlings should not dry up. So, this the seedling emergence takes place, and within 15 days you should go for the transplanting. If you delay transplanting, because there is no sufficient supply of nutrients to the seedlings, because this is grown in a limited soils over the plastic sheets, and the seedling becomes yellow after 15-20 days. So, you have to go for transplanting, and you can use only 1 seedling or maximum 2 seedlings per hill in case of the SRI technique, and the spacing is wider, we give 25 centimeter, and this has advantage over the conventional technique, conventional planting. Having wider spacing, young seedling is expected to have the better yield as compared to older seedlings, and the wider spacing means it provides the maximum space, good space for a particular seedling, 1 or 2 seedling, to get the nutrients, optimum water and nutrients for a proper growth and development. Having 1 seedling or the 2 seedling per hill, so that has a more number of pillar formations as compared to the conventional practice, where you are using 3 to 4 seedlings per hill, and the spacing is narrow spacing around 20 to 15 centimeter. So, that way the SRI systems, the system of rice intensification, that have the better yield as compared to the conventional practice. And of course, as you are maintaining the saturation water, we are not giving the standing water while providing saturation water and the standing water. In case of the saturation water, there is a proper exchange of air between the atmosphere and the soil surface, and that helps in the better formation of tillers. And in SRI, if you especially during the tillering operations, if you only use 1 centimeter water and use a rotary weeders in the inter-row areas, so that causes also aerations in the soils and the atmosphere, that and also that helps in removing the older roots. Older roots are pruned, they are cut, they are mixed in the soils, that helps the formation of the better root systems. So, by this way SRI systems having the less water, exchange of air between the atmosphere and soil, that becomes better, that helps in the more and more tiller formation as compared to conventional. In conventional you may have the tillers around 20 tillers per hill, but SRI the tillers may go up to 30 tillers per hill. So, that because of higher tiller formation in SRIs, that due to the wider spacing, young tillers and the shallow water levels, saturations, that helps in more tiller formations, and if the tiller formation increases, so that ultimately leads to more number of panicles, and having the more number of panicles, that causes in higher yield. So, the research report has given the variable informations about the enhancement yield in SRI as compared to conventional practice. If you maintain SRI very scientifically and accurately, there will be around 20% yield improvement in SRI systems as compared to conventional practice. And moreover, having the SRI systems, you are saving the huge amount of seed, because in case of conventional practice the seed requirement around 50 kg per hectare. In SRI this is only 5 kg per hectare. That way you are minimizing around 80% of the seed requirement in SRI systems as compared to conventional. And further also water management. So, as you are maintaining only saturations, no standing water is required. Standing water never leads to the improvement in crop yield. As you discussed earlier also, having standing water, that causes the reduced conditions in the soils, and also that causes the loss of nitrogens as a loss N2 losses, yield management of fertilizers, and also there is methane emissions. Having standing water, that causes more emission of methanes as a global warming potentials. But maintaining saturations, so you can minimize the emission of greenhouse gases either from methanes or nitrous oxide from the crop field. That way you can minimize the global warming potentials. So, being the SRI systems, usually for the organic farming system you go for system of rice intensifications, you can minimize your the seed requirements, because 80% seed requirement can be minimized as compared to conventional practice, as you are using only 5 kg per hectare seed for SRI against 50 kg per hectare in case of conventional seeds. And moreover, the water also you can minimize the water requirement around 40% with maintaining saturations only. Without going for standing water, you can get the better yield as compared to the conventional practice. So, this is way. So, system of rice intensification, that we are going for the organic farming, and you can, in addition to that, you can go for the nutrient management, transplanted rice or the direct seeding rice. You can go for the green manure cultivations. When you go for the organics, so green manures means green manure crop of Sesbania aculeata and Crotalaria gentiana. So, that can be taken. The 60-day old crop can contribute approximately 100 kg nitrogen per hectare, 25 to 30 kg P per hectare and 75 kg K per hectare, and this can meet the requirement of organic crops. So, if you are growing the green manure crops before the rice and the seed rate is around 25 to 30 kg per hectare for Sesbania, and the sowing time last week of April to first fortnight of the May, and this is incorporated plowed back in the field. So, before when you go for land preparation, when the crop is around 55 to 60 days, because it is a fleshy stage at the vegetative stage, and that can be plowed back, and at this stage if you incorporate in the field, that can be well decomposed in the field, and the nutrients can be easily available for the rice crop. By doing green manuring, you can minimize the nutrient requirement of the crops, because as you are going for the, if you go transplanted rice, as you see this way you can go for the incorporation of green manures, and during the land preparation or the puddling operations, they can be plowed back in the soils, and that can be those as is a vegetative stage and succulent, very succulent, and that can be those things can be well decomposed. And also you can use using farm-made manure, then a well decomposed farm-made manure should be applied around 50 to 20 tons per hectare, which can supply around 75 to 100 kg nitrogen per hectare, 35 to 40 kg P2O5 and 75 100 kg K2O per hectare. So, FM should be decomposed by you can add the trichoderma species fungus, that can be added also to the FIM for a better decompositions, and it can have the effect on the field also by avoiding any insect pest and diseases. We can go for enriched compost, like the various methods of composting for a nutrient enrichment through either rock phosphate, pyrite, microorganisms have better quality with respect to N, P and K as we discussed, rock phosphate or the dolomite or the mica, and the microorganisms can be enriched in the compost preparation process. We can have a enriched compost productions, and we can have the azolla, the inoculation of azolla biofertilizer at 7 days after transplanting a rice crop at 2 ton per hectare in standing water, and its growth during the rice crop add organic matter and nitrogen to the soil. Azolla also can be incorporated at the time of purling of rice field at 6 tons per hectare, also can provide around 25 to 30 kg per hectare the rice crop in organic farming systems. Vermicompost, after vermicompost at 5 ton per hectare can meet the nutrient requirement. So, what is say this is I could go for the, when you go for the organic farming, especially as rice we are discussing is a, it requires nitrogen. Cereal crops, they need the continuous supply of nitrogen at the critical growth stages for their better growth and development. Unlike the vegetable crops, like we discussed potato or the that needs more of potash. Potash, so this organic manure that are applied at the beginning, and there is a slow release. Unlike the chemical fertilizer, they have a fast release, and if the nutrients are not taken up by the crops, the nutrients are lost. But organic nutrients, the slow release, decompositions and the slow mineralization process, and the nutrients what are released, they meet the synchrony with the crop demand, and loss is less as compared to the chemical fertilizers. In case of vegetables, as their demand is for potash or the phosphorus, different nutrients for the in case of the potato or the tomato, and those applying the organic manures at the basal applications, and with the slow mineralization process they can meet the nutrient requirement during the growth stages. And those crops like your potato, tomato, vegetables, they are the indeterminate crops, means so they are the growth phases like vegetative or the reproductive, they are not synchrony, because the vegetative and reproductive they are overlapping, they continues parallelly. They have because potato, you can see tomato, we do not harvest tomato all fields at one stage, because harvesting starts from one stage and it may continue for 15 days or 1 month depending upon the fruiting. But this does not have, this is because of the overlapping of vegetative and reproductive stages, and this does not happen in crops like cereals and wheats. When you go for the cereals, rice crops, we do not harvest in stages, we harvest rice when matures at a particular time, not like tomato as a staggered harvest. So, because the rice is a determinant crops where the stages are very specific, and that is why the nutrient requirement is also very specific. We need the nutrient requirement at particular growth stages. So, rice has the different critical stages as say tillering stage, panicle insertions and the flowering, as discussed earlier also earlier classes, because if you see the nutrient demand, that will be higher in case of tillering and panicle insertion in addition to the basal. Basal leads to the initiation of tillers, and if you apply the nutrients at the tillering, that leads to maximum tiller formations, and after that if you apply panicle insertions, that leads to maximum grain formations. So, to meet the N requirement at specific growth stages, having the organic, either the green manures, as you say you have to go for green manures, so that the release is very slow and the loss is very less. Having green manure crops or applying the enriched compost or azolla or the vermicompost. So, you have to meet the huge the amounts, because very high to meet the N requirement, and in this case we can also go for the split applications to meet the requirement at least in one of the critical stages. We have seen from our experiment also, if you go for the split application of vermicompost, especially at the time of the 50% at the time of the land preparations or the planting times, and the rest 50% just before panicle insertions. So, you can maintain the yield level same as of the chemical fertilizer. At the same time, this will have also the higher residual effect for the subsequent crops. Because unlike the chemical fertilizer, because as you are applying chemical fertilizer exactly at the critical stages, so that boosts the yield of the crop, we can get the higher yield. But having the organic fertilizers, mixing also proper mixing the fertilizers with the soils, that is very essential to have a better availability of the nutrients. So, that can be possible only during the basal or during the land preparation. That is why you apply the most of the organic fertilizer at the time of land preparations, and moreover it has a slow release, So, not like chemical fertilizer, nutrients are not fast release very slow due to the slow process of mineralization of the organic fertilizers, and that meets the nutrient requirement of the crops. So, throughout the as per the growth stages, and that can avoid the loss of yield. But however, for the especially for the rice crops, if you see the integrated the organic and the chemical 50-50, that is giving from the experiment that giving the best result as compared to the only only organic, because you need the you have to, by doing integration of the chemical fertilizer and the organic fertilizer, you can minimize the requirement of the vermicompost at the beginning of the organic farming. So, later on when the soil gets built up, maybe after 10 years continuous applications. So, in that case you can minimize the use of chemical fertilizer and completely depends upon the organic fertilizers for the rice productions. So, this is about the then we will discuss about this is about the green manuring or use of the biofertilizer, azolla or the vermicompost or the enriched compost in the during the land preparations in the for rice cultivations. Then we will discuss how to calculate the doses of nutrients for the rice, and also we will discuss the wheat, the management of the wheat crops in the next class.